Hi everyone, this is an announcement for Vapor's upcoming currently released version, version 3.7.0. And this is a very special release for us because it comes with a scriptable interface where you can use Python to run Vapor through a Python script. And in this introduction to 3.7.0, I'll be touching base on how to get started with that whole package. So yes, 3.7.0 comes with the Python API that allows you to script with Vapor. We also have an enhanced particle renderer. So if you are rendering Lagrangian particle tracers, we have new rendering capabilities for that use case. I'll be showing you guys how to use that. And then the last thing I'll touch on is a new dataset metadata panel that allows you to interrogate the properties of your data from within Vapor, so you don't have to use something like ncdump to find things like the coordinate variables that pertain to your scalars and other things like that. And in addition to that, we also have 93 other minor enhancements and bug fixes with 3.7.0. So with all that being said, let's get started. And I will be starting with the Python API. So if you want to get started with Vapor's Python API, the first thing you're going to have to do is install a package called miniconda. So to do that, let's see, just do a search for miniconda, maybe your platform. And Conda is basically just a package manager and environment manager for Python, which allows you to have different Python environments and easily switch between different environments without corrupting each other. So after searching for miniconda OSX, I'll go to the top link and scroll down. Let's see, download the installer for Mac OS. And of course you would go to whatever OS version you're currently running and just find the installer. Here they are for Windows, OS X, and Python 3.9. I'm going to go with this one, Python 3.9, which is the version of Python that Vapor uses. It's important to match that version. And I would download this one and install it, but you can see down here in my downloads toolbar, I've already done that. Installing takes a few minutes, so I'm skipping it for the sake of the video. And if I go to my terminal, let's see, I'll just maximize it and I'll start from my home screen. And I can, so I've installed Conda by running that script that I just downloaded. And then once I've done that and restarted my shell, I can use the Conda, application. So if I type Conda, it'll give me a whole list of options. And I guess one of them that I'll start off with is Conda env list. And this will show me all the environments that I have in my current Conda installation. Right now I only have one. It is the base environment. This asterisk indicates which environment is active. If I had multiple environments, I would see them all listed below base. The first thing I'm going to do is create a new Conda environment derived off of base for Vapor. So the first thing I do is conda create -- name Vapor. Go ahead and follow the dialogues, and I think that did it. So now when I do conda env list, you can see I have two environments, one Vapor, one on base. I'm still on base though, so to go over to Vapor, I will do conda activate Vapor, and then conda env list to now see that my asterisk has now moved down to the Vapor environment. The next thing we need to do is download Vapor's Python package. And so what I'm going to do now is go to our GitHub page. Let's see, I'll just navigate to, clean up some of these tabs while I'm at it. So here I am at Vapor's GitHub page, and we can go to our releases where we have all of our downloads. And over here at the very top, we have Vapor 3.7.0. And in our assets, we have these Python API packages. We have one for Linux and one for OS X. We currently do not support the Python API on Windows. We might get to that next release, but currently it's only Linux and OS X. So since I'm on OS X, I'll go ahead and download that. And in fact, I think I probably already have it. If I go to, if I do ls in my downloads directory, that's probably the second copy I have. So sort by time. Yeah, so I already have it right here. I'm downloading a duplicate copy, but I'm going to reference the one I already have. I'll say for the record, all these steps I'm doing, I should have said this up front, all these steps will hopefully be unnecessary. So if you're watching this video from the future, then hopefully all you have to do is install Conda like we've already done, and then just do Conda install Vapor. And what we're trying to do is get this package hosted on a repository called Conda Forge, which will allow you to just install it as a one-liner with Conda install Vapor. But since we're not currently hosted on Conda Forge, you have to follow these steps by downloading the actual package that we host on our GitHub page. But I'm going to stop that right now because it's going to fail because there is no Conda package for Vapor yet. So back to what I was doing. Let's clear things out. If I let us on my downloads, we can see I have my Python OS X package right here. That's what I'm going to target. What I have to do is create what is called a channel. Conda listens to different channels, which are repositories of different packages. We're trying to get Vapor onto the Conda Forge channel, but since we're not there yet, we have to create our own local channel on our local system. And so what we have to do now is make we have to make a directory called channel, and I think I already have one. Mine already exists, so I'm just going to clear it out. And then from there, if I cd into channel, I need to make a directory that pertains to my current operating system. So I'm going to do another make dir. This is OS X 64. But if you are on Linux, you would be doing Linux 64. I'm not using Linux 64 for this, so I'm just going to remove that. All right, so now I have my channel directory with my operating system directory. From there, I'm going to move my downloads, Vapor 3.7.0, Python API, OS X, not Linux, and then the tar.bz2 file into my OS X 64 directory. So if I clear everything, and I do an ls, or let me go up one directory. So if I do an ls on my channel directory, you can see I have my OS X 64 directory, and if I do an ls on that, you can see my Python tar.bz2 file. The next thing we have to do is add this channel, or point Conda to this channel, and that's done through a command called index. So next let me clear that up. So to index my channel, I will do Conda index channel, and this will tell Conda to take a look at my channel directory. I have a package there that I'll want to install later. There we go. Before I install, what's going to happen is Conda is going to look at Vapor's package, and it's going to look at all of Vapor's prerequisites, all of our third-party libraries. And Conda is going to need to look for those third-party libraries from different remote channels. And so what I have to do next is do Conda, Conda add Conda Forge, I believe. Whoops. Conda, no, it's not Conda add, it is Conda, let's see. Conda config -- add channels, Conda Forge. So again, that's Conda config add channels, Conda Forge. That will allow Conda to interrogate all the packages that are on Conda Forge so Vapor can collect its third-party libraries and requirements. And I guess I've already done that. So Conda Forge is already in my channels list. It's being moved to the top in priority. And so it will look for the third-party libraries based on the packages provided by Conda Forge. Finally, I'm all configured. The next thing I'll do to install the Vapor Python package is Conda install-c file : / and then we put the full file path to our channel. So my full file path is users Pierce channel, and then finally the package name that we want to install, which is Vapor. And I'm not sure if I uninstalled this. You know, I install and uninstall this package, you know, recently before release. I've been doing this multiple times a day. I'm not sure if I currently have it installed or not. I suspect I didn't uninstall it before doing this demo. So, what I think I'll do for the sake of time, because this can take a little while, I'm going to open up a new tab. And let's see, I'm going to go ahead and do conda activates Vapor. And then now that I've activated Vapor, I'll just go into Python. And let's see, let's try importing Vapor. No module found called Vapor. So I haven't installed it yet. I will probably have to trim this video. So I will see you guys when I get back. Okay, and now we are finally back. As you have seen on the screen, Conda has downloaded all of the prerequisites for Vapor and now installed Vapor. So now that that's been done, I can now execute Python in my current Conda environment, and I should be able to import Vapor. And there will be a few setup steps, but after that, I should be able to use everything in Vapor at my fingertips. What I can do now is load in session files that I've configured through Vapor's GUI, and then operate on them, create renderings through the Python interface. But the best way to do that, and the simplest way to do that for this video, is to show you guys some of the examples that come with the Python package that I've just installed. So to do that, I will go to my Conda directory, wherever Conda was installed, and I can find that by typing echo Conda prefix, and this is where my current base path to my current Conda environment is. So if I cd into that directory, I have all these binaries, executables, libraries, and within the library directory, I believe under Python 3.9 site packages, it is now under Vapor. Yes, so now that I'm in site packages, cd into Vapor, I'll do pwd. You can see it's a long path, I know, but the Conda prefix is described by this path up until Vapor, and then within lib Python 3.9 site packages Vapor, you'll find our examples. So I'll go into my examples directory, and within this directory you can find all of our Python examples. In addition, you can also go to our example notebooks directory, where you can find all of these Python examples in Jupyter Notebook format, so you can launch them in a Jupyter kernel. For simplicity's sake, I'm just going to take a look at, how about Dataset example. I think is a pretty simple one, so I'll VI on that. And you can see the first thing we do, there's all these modules that we have to import from Vapor. Session allows you to load in sessions. Renderer allows you to operate on and create new renderers. Dataset allows you to load data, and then camera allows you to move the camera into different positions. So we go through and we create a new session by instantiating the session.session object. Our dataset will come from our example utilities module. That was the first thing we did. We imported example utilities. And then we can open an example dataset with the session we just created. And if we scroll down, there are some diagnostics that get printed out about the data set. We create a new renderer. We set the variable in the data set by acquiring the data variable names from the data object. And I guess we are selecting the first 2D variable. We are getting the camera and setting a viewpoint to view everything, and then we do session.show, and that will create a simple rendering. So if I quit out, and I do Python dataset example.py, we should first see those diagnostics in the example, and then we should get a pop-up window that shows us the very simple first rendering that we've done. we go. There's our metadata, available variables, and here's our very simple wireframe rendering in our dataset example. So I'm going to keep this video shorter, but we will have more tutorial videos on how to go more in depth with the different functionalities within Vapor. One thing I will note that's pretty useful is if I run Python, and then let's say I import Vapor, or how about if I do from Vapor import session, and if you guys remember, session was one of about 5 different modules that we imported to do those operations. If I do a help command on any of those objects, so now that I've imported session, here we can find all of the available well, tools and utilities. Let's see, how about a renderer is probably a better one. If I do from Vapor import renderer. Here we can see all the different classes that derive from renderer. Here's our barb renderer, and here's all the functions that we can use to get and set different parameters on the different renderers. And so if I wanted to, for example, do something with the volume renderer, I would just search for volume, and here we would see all of the available Python bindings that let us operate on and query our volume renderer in that way. And the other classes work the same way. Pretty much all those other modules that we imported, the camera, the session, renderer, and gosh, I forget what the other one was, but you can basically call help on any of them and get a feel for what you can do with those different objects just by calling help. So again, I will be doing a more in-depth Python tutorial in the near future, so keep your eyes peeled for that. Enable the Vapor notice board if you want to get notifications for when these things are announced. That might help. But yeah, that's the Python API short tutorial, I guess. The next thing I want to talk about is the new enhanced particle renderer. And so Vapor supports Eulerian simulation data, which is all gridded data, but we also support now, at least as of 3.5.0, we supported Lagrangian particle simulations. But the rendering capabilities we had for it were limited. We were only drawing GL primitives, so you could basically see lines or individual pixel dots. Now we have enhanced rendering capabilities that allow us to draw glyphs. And so to jump into that, let's kick Vapor started. So I'll go down here and click on my V. And I'll just show the functionality first. So I'll go to File, Import, DCP, that is Data Collection Particles. That's the data format that we call, well, it's a data format that Vapor supports. And I'll talk a little bit about that data format after I show the functionality. So next I'll go to my data directory, DCP, and I will select all these particle files. And if you want to try this at Vapor at home, like if you want to experiment with a particle renderer, Vapor comes with a script that will generate particles for you. So that's the wrong window. I'll show you how to generate these particles real quick. So if I go to the installation directory where I've installed Vapor, so I cd into OS X, it's going to be applications, Mac, oh no, where is it? Applications, vapor.app, contents, Mac OS, there, actually, is that? No, I think it's vapor.app/share. No, contents, share, there it is. On OS X, OS X kind of makes their installation directories a little more complicated than it does on Linux. On Linux, Vapor will just install in whatever directory you tell it to, and then from that directory you just go to share, and you can find some examples. So if I cd down to examples, there's a generate example dcp.py. So again, if I show you guys where I'm at right now, I've installed Vapor into applications, vapor.app, and from there, go to the contents directory, share directory, to examples. From that directory, you'll find generate example dcp.py. I'll do Python, generate dcp.py. And once that happens, these particle files will have been generated, very small files, and that's basically the same thing that I just loaded. So if you want to try this at home, you can find that script, generate those particle files, load them into Vapor under the DCP file format, click on New, double-click Particle, and then enable it. And then right off the bat, you can see, if I go to our Appearance tab, previously, I can turn off this Enable 3D Geometry, and I don't know if you guys can even see, there's pixel-sized particles in there that I can play forward and backwards. I'm not sure if that's even showing up on the screen. But the new rendering functionality, if you enable 3D geometry, draws them as glyphs, and you can animate those backwards and forwards through time, and color them according to a primary variable name, and you can also like adjust the stride. If you have 100 billion particles, you can operate on the stride parameter. So in this example, I have 200 particles. If I wanted to reduce that to just one, I would enter a stride of 200, and there I have one particle, and Vapor will render a little bit more quickly, and you won't be querying as much data. If I wanted to show just 2 particles, I believe stride of 100 would do the job, and then there's my 2 particles bouncing around. That's pretty much that. I'd like to talk a second about the DCP the DCP data format, because I don't think most Lagrangian simulations output in this format, but it should be pretty simple to convert your data into the DCP data format for use in Vapor. So I'm in this directory where I created all these particle files. What I'm going to do now is do an ncdump. I'll just do ncdump. I'll do the whole thing on my first particle file, pipe less. So this is a description of our particle file. Each particle, well, there are 3 dimensions. P is the number of particles. T is the time dimension, and that's set to unlimited. Every particle file can only represent one time step. So your T dimension needs to be unlimited, and it can only have 1 per file. And then the axis dimension we set to 3 because it's 3-dimensional data. 4-dimensional if you include time. The variables, we have to have a time coordinate variable with a unit of whatever you like, seconds, minutes, etc. It just needs a unit variable to it, and then a value, and again, only 1 time value per file. In this file, time is equal to 0 because it's the first time step. Another variable we have is position, which is a function of time, the particle number, and it has a 3-component axis. So we can see that right here, our position per particle. You can see the fastest moving dimension is axis, and so we have our x, y, and z, I believe, coordinates on a per particle basis. So our first particle has these coordinates on x, y, and z, or z, y, and x, I believe x, y, and z. The second particle has those coordinates, and so on. And that describes to Vapor where it's going to be drawn in space. You can also have other variables that are kind of vectorized, like velocity, or you can have more of a scalar variable like speed, which is only a function of time and the particle number. And if I go down far enough, let's see, where is, here, I'll go to the top and type speed. And here we have, basically, this is just 1 value per particle, a long list of values, and we should have 200 values here that describe speed. Did I close Vapor? No, I still have it open. So if I go back to Vapor and I do a stride of 1 so we can see all of my particles, we can see that the variable that I'm coloring by is speed. But I can also choose other vector variables like velocity. So yeah, that's basically a brief descriptor of the DCP data format. If you guys have any questions on that, feel free to contact us on our forum. The final feature I guess I wanted to share is the metadata analyzer. So if I restart Vapor and let's say just open up a WRF data set, I can create a new renderer. I'll do a slice for simplicity's sake. And when I do that, in my variables tab, I have a variable metadata section where I can click on different variables, find out their minimum, maximum values, dimensionality, their coordinate variables, as well as any attributes that coincide with that particular variable. The variables shown over here will only be relevant to the current renderer. If I want to see more metadata about the dataset and all variables, I can go to my Tools menu, click on Dataset Metadata, and here's a more comprehensive list of metadata for all variables in the dataset, including coordinate variables, global attributes for the file, dimension metadata, and then of course you have to select which data set you're inquiring about that way. So those are kind of three of the biggest features that come with Vapor 3.7.0. There's, I think, roughly 93 other bug fixes and issues that have been closed since we've released 3.6. But I think I'm going to leave it there. Please send us any questions to our forum or comment below. And yeah, thanks for downloading Vapor, and we hope to see you at our next tutorial. Keep your notifier on for news on tutorials and new videos that give more in-depth walkthroughs on the content that we covered today. So thank you again, and have a nice day.